Hello and welcome to episode 14 of our base builder tutorial series. Today we will visualize objects. So in the last episode we added the object type to our model, and an object represents anything that a player can choose to install somewhere in the world. And we defined the type. We wrote some tests to show the installation and where you can install and the various requirements that you need to meet before you can install. But we didn't visualize them in the game world yet. So from a gameplay perspective, you weren't seeing them on the screen. And that is something we will fix today. So to do that, we will add another sprite manager, just like the tile sprite manager, the item sprite manager, the entity sprite manager. We'll create an object sprite manager. And for today, we'll only cover visualizing already installed objects. Planned objects like install object jobs in the world, we will do in the next episode because there's some other complexity that we need to handle first. Also, I want to be able to hover over an object just to be sure that you can see where it is and what its name is. So that will be shown in the bottom bar where you can also see the coordinates, entities and items that you hover over. So let's get started. So first, let's start Xcode. And let's see, open our project. And let's start by adding a new file, our ObjectSpriteManager. And this one will need SpriteKit. And this will be a final class, SpriteManager, and it will conform to the SpriteManager protocol. It will have a Z position and it will have a cell size, just like the other sprite managers. And again, it will have a cache for the object textures. This will be a dictionary that maps from a string to an SK texture. And autocomplete is still not working, and I still haven't heard anything back from my bug report yet, so we'll have to do this without the support for autocomplete when it comes to SpriteKit types. So the other one will be an object sprite map, and this one will keep track of all the object sprites we have in our world. And we need an initializer that takes a cell size, and that takes a position, and it will set the cell size, and it will take a Z position. Okay, so every sprite manager needs a function redraw, and this redraws the world in a scene. And they also always need a cleanup function. Let's implement the cleanup function first. So we'll take this is very similar to some of the others. So we create a variable objects to remove equals a vector, and we will go over each position and node in our object sprite map, and we will check if in the world, and we need to check it a specific object anchored location. If this one is nil, then we remove the node from the parent and we will add the objects to remove. entry as well. So we will remove the one at a specific position. This return gives us an array of objects to remove. Then we go through each object to remove. We take an object sprite map and we remove the value for key remove. So this is our cleanup function. Now let's see. So to show objects in the world, we need to go through each object position and object in world.object. Then we need to get a texture, and we will again use a function here, get texture named, and then the object.sprite. So let's implement that function. This is our cached object textures function. Create a function. It can be private. Get texture named, and this takes in a texture name, type string, and this returns an SK texture. If we already have it in our cache, we can just return the texture. Otherwise, we will need to find it and add it to the cache. So our texture will be an SK texture, one image named texture name, texture filter mode will be nearest. So we want a nice crisp zooming effect. We have an object texture map with a texture name that we set to our texture. This is where we cache it and we return the texture. Now we should have a texture here. Let's go on. The second step is to use a new function, and we will call it setObjectTexture. This will pass in a texture, an object, to the position in a scene. And again, this function we need to implement. It's quite similar to the other functions in the other sprite managers. We will create a private function called setObjectTexture. This takes in a SK texture, an object, position in a scene. And then let's see. So first we see if we have a node already in our object sprite map for this position. And if we do, we set the texture to the texture that was passed in. And we set the node's position to the CG point, where we take our cell size and we multiply it by the CG float cast value of position.x. Because those are integers, and we do something similar for the y position. If we don't have this, we don't have it in the object sprite map yet. We need to create a new node. We create an SK sprite node, with the texture that was passed in. We set the size for the nodes, and this will be a CG size with the width cell size times CG float object size.x. And something similar for the height, so we take our cell size and multiply it by the object size.y. It also needs to have the correct position. It needs to have a Z position. It needs to have a color blend factor, so we can recolor it later. And we give it some user data. And we give it the object position as a key and position as value. We add it to the scene. And we add it to our object sprite map. And this should be enough for our ObjectSpriteManager to show objects in the world. So let's put this up. Let's see. So we need our game scene. We need to add an ObjectSpriteManager. So let's create one. This will be an ObjectSpriteManager with cell size. And the Z position for this one will make it 0.2. This way the objects are below the entities and below items but above tiles. Also in the redraw function we need to take our ObjectSpriteManager, redraw the world in. So, and of course we want something to show. So let's go into our world, into where we have a demo world. Let's create an object. We'll give it a name. We'll call it a kitchen counter. It will have a size of 3 wide and 1 high. And where do we want to position it? We have our new world. Take our objects and let's say it's right in the middle. We take our object. Okay, so let's very quickly try and run this. Also, I think the assets doesn't contain a kitchen counter proper yet. It does contain a kitchen counter item. This is the small version you could put in your inventory. So I created a quick write, and the link is in the screen and in the description below. Let's see if this runs. Cell size. Let's see if these are all the typos. We're building. We're running. And we don't see the object yet. So what are we missing? So we have our redraw function. Where's our world? Let's see if our object sprite map actually gets called. Okay, so we are trying to get a kitchen counter. We're doing set the object texture map, create a new node, give it a size, give it a position, we give it a Z position. Let's look into this node. We reduce the data, we add it to the scene and to our map. Oh, I'm sorry, I found the issue. After we set the color blend factor, we should set the color to white for this sprite. So now we can see the kitchen counter showing up. So let's see if we can hover over it as well. To that, we will go to our view controller and we will create a computed variable. Let's see, we call it selected. We call it hover object, and let's put it with the other hover items. This will be an object optional, and we will get it through if let hover coordinates. So first we try and unwrap the hover coordinates, and we return the world object at hover coordinate. That could be nil if there's nothing there. Otherwise, if nothing is hovered over, we always return nil. Then we can go into our GUI and we can look over our hover entity and do something similar with if let object is a view model hover object. Then we add a text. Object.name. We add some padding, just like above. And we add a foreground color. Let's see if this works. So let's see. So if we hover over, we can see indeed the kitchen counter showing up in the bottom of the screen, but something strange is happening because I can see the kitchen counter here, but it's not showing up in the bottom. And I can hover over here, I can see it, but it's also shown in the bottom here, but not on the screen. So what is going on? And that's one of the things we need to fix today. There's a difference between the way the visualization works and the way that objects are installed in the world. So if you look at an object, the install position is the bottom left object. That's sort of the origin or the anchor of the object. That's how we defined it in our model. Also in trying to find other tiles that it overlaps. However, when you take the sprite anchors by default in the middle of the sprite. And for one by one sprites, this doesn't matter. This turns out the same. But if sprites are larger than that, then the anchor will be on a different location than the bottom left. Also, for odd-shaped sprites, this might even not look immediately strange, but if you do it for even-sized objects, you will have them half covering some other tiles as well, because the middle tile also the anchor will sort of divide it in half, and you don't have a specific cell that's the exact middle cell. So we need to compensate for this. And what I don't want to do is change the sprite's pivot per se, because we're using the same pivot, the middle pivot, in all the other sprites as well. Normally it's working quite well. What we need to do is we have our anchor, if the sprite here, and we sort of want to virtually place the anchor here, which means that we need to shift the position of the entire sprite somewhat in the other direction. So it's an offset with the same size as where you want to place the virtual anchor, but in the opposite direction. And there's some math involved. Please note that if you have a 1x1 sized object, the offset comes out to 0. So that's an indication that this works. And also this is in the result of this is in number of cells. We still need to convert that to the cell size. So there's a bit of math. Fortunately, it works both for even and odd sizes. And perhaps seeing it in action will make it a bit clearer. So let's go to our ObjectSpriteManager, and here we'll reset our object texture. Let's see if we can create an X offset, and this will be -0.5 plus. This requires some casting because the size is an integer divided by 2.0, so half the size. And the Y offset is something similar. But then at the Y size or the height, and this gives us an offset or an X offset and a Y offset. And now here where we're setting the position, what we should do is we should add the offset times the cell size and do the same thing here. I'm not sure whether this is mathematically immediately allowed, so let's try and build. Okay, so we can't multiply a point by a scalar immediately. Fortunately, we have this extension here, so we can simply create a function that implements the multiplication operator, and we will take a scalar. This will be a double. So what we return is the left-hand side multiplied by the scalar, and the left-hand side y-coordinate by the scalar as well. So this scales the vector by a specific scalar, and this should now work. So let's see if this runs. Now you can see that the kitchen counter is indeed, we place it at 0, 0 position, but this is where it starts at the bottom left. This also works for different sizes, so let's quickly hack this a bit. Let's say it's 3x2. So the sprite looks a bit strange because the sprite is scaled and wasn't meant to be this size, but at least you can see that indeed it's nice and anchored to the bottom left. It also works for even sized ones. So again, we're squashing the sprite a bit, but we want to look at positioning here. So that's working correctly. So let's go back and run this one with the correct size. Cool, that's it. So because working with the sprite offset took a bit more time, I'm going to leave it here, and we will visualize object jobs next time. It's also a bit more complicated, but we'll get into that next time. So thanks for watching and have a good day.